In this video, you will learn how to design a highway between two specific points for CE 354 project. Given design speed 70 km per hour, grade 9%, alignment 2 to 2. Highway design project. For the given map, the design speed is 70 km per hour, the grade is 9%, and the alignment, let's consider the alignment is 2 to 2. That means the highway will start from point 2 going to the other side, point 2. The given grade is 9%. What does it mean? The 9%, that means for 100 meter horizontal distance of the road, we can go 9 meter either up or down. So for the given map, we have the contour lines in here. According to these contour lines, for the thick lines in here, it's 755. Going to the other one, it's 750. That means we have each contour line here represents 1 meter difference in height. According to this, and to the scale that's given for the map 1 to 1000, that means 1 millimeter on the map equals to 1 meter on the site. Now the difference here is 1 meter. For the given grade, as said, it's 9%. 1 over x equals 9 over 100. Then x equals 11.11 meters. That means for 11.11 meters horizontal distance, we can go 1 meter up or down. And according to this, if we are going to take this distance from the site to the map, we have to take the scale of the map. Then 11.11 over 1000 equals 0.011. That means on the map, x equals 11.11 millimeter equals to 1.1 centimeter. According to this, we are going to take the lines with 1.1 centimeter distance from this point to this point, according to these contour lines. How to achieve it? First, we have to take the compass, and according to this, we take the opening of the compass at 1.1. That means we have here the ruler, and we have the compass in here. The opening of the compass must be 1.1 centimeter. According to this, we start from here. It's 1.1. Like this is 1.1 centimeter. And we start with our point in here. Starting from this point, we have to take the cut of the line on the other contour line, because from this contour line to this contour line, there is 1 meter on the side difference in height. And to achieve it, we need distance of 11.11 meter on the side. That means 1.1 centimeter here. So we can achieve by this distance the 1 meter height. Take the second one. There's no problem if we can't achieve the next one. So we have to go with the same height in here, or go with 2 lines until the second one. We should do these steps until we achieve the second point, the other one, the target point in there. For these regions in here, we have difference in height, but specific difference. The points are given. For example, we have 3 points are taken for the heights of the points in here. This one, for example, 748.5, 748. So in this case, either we have to cut or to fill this region for the road to pass from here. So there is no problem if we just cut the road from here directly, and then we can compute the fill or the cut in this region. Then we complete. Then the direction of your road will be from here, going in this manner, again going in this manner until point 2. So if we are going to draw lines in here, you just start from the line to the intersection point, going over the line here, then starting the line to the intersection points. directly, it will be just like. Or the contour line on the same height, and again coming from here to here. And the road will be something like this. But actually, we can't design such a road because there are specifics in the design of the road. We have to achieve the horizontal alignments and we have to achieve the vertical alignments correctly. And because of this, we have to consider at least 2 horizontal alignments and 1 vertical alignment during the design of the road. Now first, what we have to do is to consider these lines. We can make thousands of choices for these lines, but like we can go in this direction, we can go in this direction, we can go in this direction or any other direction. These choices give us the optimum road at the end. For example, the shortest road to connect point 2 to point 2. And according to this, we have to make many choices in here, but we just need one choice now because there is no time for other choices, and we can start the design of the highway directly from here. According to this choice that we made in here, we have first to design the horizontal alignment from this direction, then go to the vertical alignment, and at the end we can design another horizontal alignment. So to start the design of the horizontal alignment, first let's consider we go in this direction. Now there is idea in here in order to get the 2 horizontal alignments the same with the same details, so we can only design 1 horizontal alignment and apply all the details on the other one directly. So we just take the second horizontal alignment parallel to the first one according to how to take it. Let's say in this direction. So we take the first line, then coming from here, we have the second line in here the same, so we can take it from here directly. Okay, and in order to connect the lines with each other, consider of the third line. Now here we have the tangents of the horizontal alignment. Tangents of the horizontal alignments 1, 2, and 3 lines. Approximately the same direction that we considered as the first. Then the design of the horizontal alignment. How to design the horizontal alignment? Now, according to this highway, the highway will start from point 2. First horizontal alignment goes in the straight manner, second horizontal alignment until we achieve the second point. Here, according to what we studied for the horizontal alignments in here, this book is the Transportation Engineering, and the page 78. So we have the design of the horizontal alignment. In order to design the horizontal alignment, the first thing is to compute the value of delta. This delta represents the deflection angle of the horizontal alignment. Now, according to our road, with the same manner, here, the road comes from this point and goes in this manner. So, the value of delta, if we compare this figure with our figure, it will be in here. Okay? This is This one will be the same as this. Let's consider this as delta 1. How to compute delta 1? We have to use this ruler. This one. We have to use it. We take the center of it on the intersection point here. The 2 points, it's very important to take it on the line in order to get the correct angle here. We put the center of the ruler on the intersection point. And starting from 0, this is 30, 35, 6, 7. So it's 37 degrees. This one is 37 degrees. Because the design of the first horizontal alignment and the second one the same, we take the lines parallel to each other, then delta 2 will be equal to 37 degrees for the second horizontal alignment. Now starting in here, it's delta 1, 37. What we have to do then? First, we start with the computation of L and T. What's L? The length of the circular curve. The length of the circular curve. And T is the semitangent of circular curve. So we start with T at first, then we go to compute L, and then in EC in here. Starting with T. T equals R times tangent delta over 2. R equals 250 meters. Delta equals 37 degrees. T equals 250 tangent 37 over 2. That means T equals 83.65 meters. On map, T equals 8.4 centimeter. Starting from the intersection point. Now here, look, the T represents the distance from the intersection point here until the end of the horizontal alignment. And according to this, we start from the intersection point. We take the value of 8.4, let's say. So from the intersection point in here, this is 8.4, and on the tangent, it will be this point. This point is known by the tangent to the circular curve. So we can say TC, tangent to circular curve. By the same manner, on the other direction, we start from the intersection point and goes in 8.4 centimeters. This point is known by CT, YCT, because circular curve to the tangent of the horizontal alignment. After this, we have to achieve the horizontal alignment. How to get the horizontal alignment in here? First, we have to compute the length of the horizontal alignment using this. So L equal to pi R times delta over 360, or directly R times delta radian. It will be 161.44 meters. After the computation of L, we have to measure here the value of M, middle ordinate, and we have to compute the value of E, external distance. These values are shown here on the figure. These values are important in the computation of the horizontal alignment. Now, how to achieve the horizontal alignment here? What we have to do, we take the compass again, and we take the ruler. As we said, our radius is 250 meters, so we have to achieve this radius in order to get the horizontal alignment, which means the circular curve of the horizontal alignment. Starting from 0, we open the compass with 25 centimeters. So we start from 0 here. We start from 0 and take the 25. It's approximately, 25. Then We take the compass on the first point, which is tangent to curve point here, and we draw a curve. Same, we take it at the end of the horizontal alignment, which is the curve to the tangent point, and draw the second curve. We have to intersect these curves with each other, as here. Now the intersection point in here represents the center of the circle with a radius of 250. Then, if we set the compass on this center, like this, we can go from the start point to the end point. Okay, we can go from the start point to the end point of the horizontal alignment. So this is the start and this is the end, and we can achieve it, for example, in this manner. So we draw now the first horizontal alignment. We are going to draw the second one with the same manner in this direction. Because the first and the second one with the same details, so we can take the distance, the semi-tangent distance, the same, which is 8.4. So approximately this is 8.4 from the intersection point on the tangent. This is again the tangent to curve TC, and from here we have 0 from the intersection point, 0 point, until the end point, which is nearby the curved tangent point CT. Again, with the same manner, we have the compass in here. It must be about 25 as the radius. So this is the 25. Again, what do we have to do? We start from the first point, and it's out of the map. Okay, take this first curve for the second curve in there. So we get the intersection point there. Again, we set the intersection point like this, and we have to go from the first point to the second point for the horizontal alignment. It must start from here with the 25 and goes until the second point. So we can draw it in this manner. Now, what did we do? We designed the first horizontal and the second horizontal alignment as in figure. Our rate starts from this point to goes with straight line until the beginning of the first horizontal alignment, then straight line, then the second horizontal alignment until the end of it. It's about here. Then again we have the straight line until the second point. Now, in order to make the horizontal alignment feasible, we take the radius until the center here, this one, and the second point from here to the intersection point of the horizontal alignment. Again, here the same, from the intersection point to this point, which is the start point, and the intersection point, which is the center, to the second point. 1, 2 horizontal alignments. In order to complete the computation of the horizontal alignment, we just apply this equation. As we said, we take delta in radians, and we said how to compute delta in radians. For the middle ordinate, we take r minus r times cosine delta over 2, delta here in degrees, and we have e, which is the external distance, is taken as r, 250, delta in degrees, it's 37 degree for our example, and r. For the chord, we take 2 times r, 250, sine delta over 2, and again delta is taken in degrees here. In the next video, we will speak about the computation of vertical alignment. Now, after the horizontal alignment, as it can be seen here, the road is going over 1, 2, 3 contour lines. So how we are going to achieve the connection between this point and this point? Either we have to make a sag, or the other type, which is known by the big vertical alignment.